Hello everyone, it's Brendan. What I've got for you today is a short video describing how to perform the mechanism for the hydration of an alkene. What we can see we have here is an alkene, such as something with a CC double bond, reacting with water in the presence of a catalytic amount of H+. We know it's a catalyst here because it's written just above the arrow. Now, what happens in this mechanism is this pi bond is very nucleophilic. Hydrogens are electrophilic. So this comes here and it's simply going to grab the hydrogen. Now, once this alkene has grabbed the hydrogen, there's one of two places that the hydrogen can go. It can either go on the carbon on the left side or it can go on the carbon on the right side. And what we're going to find is that it's going to go towards the carbon on the left side, because when the hydrogen goes over here, that means that the carbocation is going to be left right there on the more highly substituted carbon. Any addition reaction that proceeds starting with an alkene through a carbocation intermediate is going to have the more stable product form as a result of the more stable intermediate, which is more highly substituted carbocation. So once we know that positive charge is right here, a water molecule, because this is an aqueous solution, there are water molecules everywhere. These electrons are very nucleophilic, so they're going to come here and attack the very electrophilic carbocation. Now, once this happens, we can see that what we would have is a water molecule that has now formed a bond to this carbon. So this would be O, H, and H with a positive charge right there. So what's going to happen next is, again, we're just in water. There's water everywhere. So another molecule of water is going to come in, grab this hydrogen, kick that bond back to the oxygen. And what we're going to end up with is an alcohol, where that alcohol has ended up on the more highly substituted carbon across the double bond. So just a few things to note. Again, remember with arrow pushing mechanisms, the back of the arrow must always come from an electron, and typically it's going either towards an atom or towards another bond. We can see that happening in each of these cases. The back of this started with the pi bond. The back of this started with the lone pair. And the back of this also started from the lone pair. And we have to account for where every set of electrons go. So if we look at this bond right here, it was very important that we drew this arrow in order to verify that these electrons did in fact end up back on this oxygen. Now we have a lone pair here. And that's basically how you do that. That's how you perform a reaction of a hydration of an alkene. Thanks for watching.